Hey everyone, in this episode we're going to discuss what are DAX or the DynamoDB Accelerator, API Gateway Caching, ElastiCache, CloudFront, and MemoryDB, and what is really the best caching service and what are the pros and cons. So each of these AWS services has specific use cases, and the best choice depends on your application's requirements. Here's a comparison of DynamoDB Accelerator or DAX, or API Gateway Caching, ElastiCache, CloudFront, and MemoryDB, with their pros and cons. First is DynamoDB Accelerator or DAX, DAX. It's a fully managed in-memory caching service specifically designed to accelerate DynamoDB queries. Best for applications using DynamoDB that requires microsecond level latency for read-heavy workloads. For pros, low latency, microsecond response time, seamless integration, automatically synchronizes with DynamoDB, managed service, no infrastructure to manage, a cost-effective, reduces the need for high read capacity units in DynamoDB. For cons, DynamoDB specific only works with DynamoDB. Limited use case, not suitable for other types of caching or non-DynamoDB data. Write operations does not accelerate write operations. Okay, number two is API Gateway Caching. So it caches the responses at the API Gateway level to reduce backend load and improve response times. Best for reducing repetitive backend calls in read-heavy API workloads. So for the pros, reduced backend load, fewer requests to the underlying service, integration native to API Gateway, TTL customization or time to live, control cache expiration for fine-tuned data freshness. Cons, limited scope, only works for API Gateway responses. Cost, cache prices can increase with size and region. For complexity, may need careful design to handle cache invalidation. For ElastiCache, for number three, Redis or Memcache, a general purpose in-memory data store and cache service, best for applications requiring caching for a variety of use cases such as session management, leaderboards, or frequently accessed data. For the pros, flexible, works with multiple data sources, high performance, low latency access with high throughput, supports complex data structures. Redis supports sorted sets, list hashes, and more. Cluster support, scalable for large workloads. For cons, manage overhead, requires configuring, scaling, and monitoring clusters. Cost can become expensive for large datasets. No automatic data synchronization, needs custom logic for syncing with databases. For CloudFront, it's a content delivery network to cache static and dynamic content globally for improved latency. Best for delivering static assets, images, videos, and dynamic content closer to users. For pros, global distribution, request latencies reduces latency for global users. Integration with AWS works well with S3, EC2, and API Gateway. Dynamic content caching supports Lambda at Edge for custom logic. Security integrates with AWS Shield and Web Application Firewall. Cons, limited write capacity primarily for read-heavy workloads. Caching logic complexity. Customizing cache behavior can be challenging. Propagation delay changes to content may take time to propagate globally. So MemoryDB for Redis, the number 5, a managed Redis service designed for primary database use cases with in-memory performance and high durability. Best for applications requiring a highly available, durable in-memory database. Pros: in-memory performance, low latency, read and write, data persistence, durable storage with snapshots, Redis compatibility, fully compatible with open source Redis, scalability, easily scales read and write throughput. Cons: cost more, expensive compared to ElastiCache for transient data, overkill for caching, designed more as a primary database than for caching, complexity, higher learning curve for advanced use cases. So for comparison table, recommendation based on needs for DynamoDB specific use the DAX for API response caching, use API gateway caching for general purpose caching, use ElastiCache for global content delivery and static asset caching, use CloudFront for durable in-memory database, use MemoryDB. Okay, so that's it. Thanks for watching. Alright, cool. Thanks. Bye.